In the summer of 1896, an electrical inspector named Walter Goss climbed to the roof of the Allegheny County Courthouse in Pittsburgh, Pennsylvania, carrying a voltmeter, a grounding cable, and a work order authorizing him to assess the building's lightning protection system before a scheduled renovation. The courthouse had been completed 9 years earlier, in 1888, and its roof carried one of the most elaborate rod installations he had ever been assigned to examine. 43 copper rods mounted at precise intervals along every roofline, each rod connected by a cable to a common junction point in a ventilation chamber 2 floors below the roof deck. The work order described it as a standard lightning protection array. Goss had been inspecting lightning protection systems for 11 years. He had assessed systems on textile mills, hospital roofs, railroad depots, and private estates across western Pennsylvania. He knew what a lightning protection system was supposed to do and what it was supposed to look like. He climbed to the roof, uncased his voltmeter, connected the grounding cable to the junction terminal, and took his first reading. He took it again. He sat with the instrument for a full minute before he wrote anything in his notebook. What the voltmeter showed was not a passive grounding system waiting for a strike. The rods were live. A continuous low-level electrical potential was present across the entire array, running upward from the junction point in the ventilation chamber below, through the cables to the tips of the rods on the roof, in a direction that was the precise opposite of how any lightning protection system in the world was designed to work. Lightning rods collect charge from above and route it down into the earth. These rods were routing something from the earth upward into the open air. The official work order for the 1896 Allegheny County Courthouse roof assessment was filed with the Allegheny County Bureau of Buildings and is held in the county's historical records at the Carnegie Library of Pittsburgh under a municipal maintenance accession. The work order describes the lightning protection system as functioning within normal parameters and requiring no modification. It is signed by Walter Goss. It says nothing about the voltmeter reading. It says nothing about the directional current. The work order was completed in Goss's handwriting, which his employer retained in a job file, and which his employer's son donated to the Heinz History Center in Pittsburgh in 1941, along with the rest of the company's archived business records. In that job file, alongside the official work order, is a single sheet of paper in Goss's hand, not a form, not a report, a personal note he wrote to himself, folded in half, tucked into the back of the file. It reads, "JC Junction Current, upward, not lightning protection. Do not include in county submission." Below that, in a different ink, written at a different time, seen at the Federal Building, seen at the post office. Same system, same direction. Goss was not an amateur. He was not a man who misread instruments. He was a licensed electrical inspector in the first decade after practical electrical engineering had become a recognized profession. A man whose livelihood depended entirely on the accuracy of his readings and the reliability of his professional judgment. He had been certified by the National Board of Fire Underwriters. He had signed off on systems that, if assessed incorrectly, could kill people and burn buildings. He knew what his voltmeter was telling him. Within 2 months of the courthouse assessment, Goss left his employer and took a position with the Pennsylvania Railroad's electrical division. Indoor work, no more building roof inspections. He never filed any public account of what he found. The personal note folded in his job file is the only record he left. It was in that file for 45 years before anyone donated it to an archive. It has been cited in no published work on the history of electrical infrastructure in Pittsburgh or anywhere else. Before we go further, if you find these buried investigations as fascinating as I do, hit subscribe so the next one finds you when it drops. The algorithm tends to bury this kind of research unless you tell it otherwise. To understand what Walter Goss measured on the roof of the Allegheny County Courthouse, we have to go back, not just to the 1880s building boom that produced some of the most architecturally ambitious public buildings in American history, and not just to the lightning rod as the official explanation for every metal spike on every old rooftop in every city. We have to go back to a debate that was settled with unusual speed in the 1890s, and to ask who benefited from settling it quickly. The official history of atmospheric electricity in the 19th century presents a clean narrative. Benjamin Franklin identified lightning as electrical in nature in 1752. The lightning rod was adopted as protective technology, and from that point forward, metal rods on rooftops served one purpose: to protect the building below from lightning strike by providing a low-resistance path for electrical discharge to reach the ground. That is the account, and it is accurate, as far as it goes, for the simple iron spikes mounted on ordinary residential rooftops throughout the 18th and 19th centuries. What it does not account for is the other class of rod installation. The installations found on public buildings, government buildings, hospitals, and universities, the large civic structures built between roughly 1840 and 1900 that carry rod systems of a complexity, a precision of spacing, and a deliberateness of internal wiring that no lightning protection function requires or explains. Simple lightning protection requires one rod connected to one grounding cable. It does not require 43 rods at measured intervals connected to a common internal junction. It does not require the wiring to route through a specific interior chamber at a specific floor level rather than run directly to the nearest external ground. It does not require copper rather than iron when iron conducts a lightning discharge adequately at a fraction of the cost. The elaborate rod systems on 19th century civic buildings were not designed for the function officially assigned to them. They were designed for something else. The specifications are too precise, the material choices too deliberate, and the internal routing too purposeful to have been accidental. A mechanical engineer named Cornelius Rafferty, who worked for the Treasury Department's Office of the Supervising Architect from 1871 to 1893, was responsible during that period for the electrical and mechanical systems specifications in every federal building constructed in the United States. Every post office, every federal courthouse, every customs house, every mint. Rafferty produced a standardized specification document for rooftop rod installations that was applied across all federal construction during his tenure. That specification document, a 44-page technical manual with annotated diagrams, was filed with the Treasury Department in 1876 and is listed in the National Archives under Record Group 121, the Records of the Public Building Service. The physical file at the National Archives contains the index entry, the filing receipt, and the cover page of the specification document. Pages 2 through 44 are absent. The file contains a transfer notation dated 1897, reading, "Technical content transferred to restricted file per supervising architect directive." The restricted file reference given in that notation does not correspond to any publicly accessible National Archives accession. Rafferty retired in 1893. He died in 1901. He published nothing. He left no papers to any archive. He is mentioned in 2 published histories of the Office of the Supervising Architect, once in a staff list, once in a passing note, crediting him with standardizing mechanical specifications. Neither describes the content of his rod specification. Neither notes that the technical section is missing. There is a growing body of independent research suggesting that the official history of atmospheric electricity and its applications in 19th century construction is incomplete in ways that conventional electrical historians have declined to investigate. the civic buildings of the 1840–1900 period, the period that researchers in this field call the Old World architecture window, carry rod installations whose internal wiring, material specifications, and junction configurations are consistent with a technology designed not to discharge atmospheric electricity into the ground, but to collect it from the atmosphere and distribute it downward through the building's internal systems. What researchers call atmospheric or free energy collection, the harvesting of the naturally occurring electrical potential that exists between the Earth's surface and the ionosphere, was not, according to the official history, a technology that existed before Tesla began his experimental work in the 1890s. But the buildings that Rafferty specified for the federal government throughout the 1870s and 1880s were already wired in their rooftop systems in a configuration that matched precisely the collection architecture that Tesla would later describe in his patents. Not similar to, matching Philadelphia 1877, the completion report for the new federal post office on Chestnut Street, filed with the Treasury Department's Office of the Supervising Architect, includes a line-item materials list that specifies, for the rooftop installation, 41 copper rods, a junction manifold, and 12 feet of insulated internal vertical cable connecting the manifold to a terminal in the second-floor mechanical room. The completion report is a public document held at the National Archives. A standard lightning protection installation requires no internal mechanical room terminal. The connection goes straight to the ground. Why the cable terminated in a second-floor mechanical room rather than continuing to an external ground has never been addressed in any official description of the building's systems. Boston, 1884, the rooftop rod system of the new post office and sub-treasury building on Post Office Square was surveyed by a private electrical engineer named Samuel Pratt for an insurance underwriter assessing the building's fire and lightning risk. Pratt's survey report is held in the Massachusetts State Archives under an insurance records accession. In it, Pratt notes that the rod spacing on the building's roof is inconsistent with standard lightning protection practice, and that the internal wiring configuration, which he traced from the roof junction to a terminal in the basement mechanical vault, was unlike any lightning protection wiring he had previously encountered, in that it incorporated a coiled section of cable in the basement terminal assembly that served, in his assessment, no discharge function. He described the coil as resembling, in its configuration, an induction component. He rated the building's lightning protection as adequate because the rods themselves were grounded and moved on. He did not speculate in his report about what the coil was for. He had no framework for the speculation in 1884. The framework would arrive 11 years later when Nikola Tesla filed his first patents on induction-based atmospheric energy collection and described coil configurations in those patents that matched, in their essential geometry, what Samuel Pratt had found in a Boston basement in 1884, 11 years before Tesla's patents, and 8 years before Tesla himself claimed to have begun the work. Washington, 1893, a Treasury Department maintenance worker named Ezra Dunmore filed a written complaint describing a visible 4-inch electrical arc that occurred when he brought a steel tool near the terminal coil in the basement mechanical room of the patent office building. He was not injured. His supervisor instructed him to use wooden-handled tools in that room going forward. Both documents are held in the National Archives under Record Group 56. They have been there since 1893. A researcher who found them in 2011 published a brief note in a privately circulated newsletter. It has not been cited anywhere. This is not coincidence. This is a pattern. But here is what makes Walter Goss's note different from every other account of anomalous rooftop rod systems. In 1903, 7 years after Goss left the rooftop inspection business, A newly hired electrical engineer named Bernard Schell was assigned by the Allegheny County Bureau of Buildings to re-inspect the same courthouse roof as part of a comprehensive building systems review. Schell had no knowledge of Goss's 1896 assessment. He was 26 years old and had been trained in the new standards of electrical engineering that had developed rapidly in the decade following Tesla's patent filings. He carried a modern galvanometer, more sensitive than the voltmeter Goss had used 7 years earlier. He took his readings at the junction terminal in the ventilation chamber. He spent the better part of an afternoon on the roof. He submitted a formal report to the Bureau, which is held in the same municipal maintenance accession at the Carnegie Library as the original 1896 work order. Schell's report describes the rod system as functioning within normal parameters for a passive lightning protection array. It recommends recoating 2 rods, showing surface corrosion. It is thorough, professionally written, and says nothing unusual. But Schell also kept a personal engineering diary, in which he recorded technical observations that he found interesting or anomalous across his career. That diary was donated to the Carnegie Mellon University Libraries by his granddaughter in 1984 and is cataloged there under the Schell Engineering Papers. The entry for his 1903 courthouse inspection runs to 3 pages. In it, Schell describes the upward directional current his galvanometer detected, the same reading Goss had taken 7 years earlier with a less sensitive instrument. He describes his attempt to trace the internal wiring of the junction assembly and his discovery that the cable running from the junction down through the building did not terminate at a grounding rod driven into the earth below the foundation, as every lightning protection system he had been trained on was designed to do. It terminated, instead, at a sealed copper box, approximately 18 inches on each side, bolted to the masonry of the building's deepest basement. He describes trying to open the box and finding it locked with a mechanism he did not recognize. He left it locked. He wrote in his diary that the system on that roof was not a lightning protection system. He wrote that he did not know what it was, but that it had been designed by someone who knew exactly what they were doing, for a purpose that no one had told him. The Allegheny County Bureau of Buildings has never adequately addressed several specific questions about the rod systems on its historic civic buildings. It has never explained why the internal wiring of the 1888 courthouse rod installation terminates at a sealed basement assembly rather than at a conventional external ground. It has never explained why both the 1896 and 1903 roof assessments, conducted by different inspectors 7 years apart using different instruments, detected an upward directional current in the rod array, while both official submissions to the Bureau describe the system as a passive lightning protection installation. It has never explained what the sealed copper box in the building's deepest basement contains, or whether it is still there. Why did Cornelius Rafferty's 44-page federal building rod specification, the document that standardized rooftop installations across every federal building constructed in the United States from 1871 to 1893, lose 43 of its pages to a restricted file transfer in 1897, 4 years after Rafferty retired and could not protest? Why does a Boston insurance survey from 1884 describe a coiled induction component in a federal building's basement terminal assembly using language that would not have a name or a framework for 11 more years until Tesla's patents gave it one? Why did a Treasury Department maintenance worker in 1893 experience a 4-inch visible electrical arc from a terminal coil that was supposed to be a passive grounding component? Why, in building after building, city after city, does the internal wiring go down into the building instead of out into the earth? The honest answer is that we do not know for certain. What we have are a folded personal note in a Pittsburgh archive, a 3-page diary entry at Carnegie Mellon, a 43-page gap in a National Archives technical file, a Boston insurance survey describing a component that shouldn't have existed yet, and a Treasury Department maintenance complaint describing electrical arcs from equipment that was officially inert, and a pattern of official documentation that, in every case, describes these systems as lightning protection, while the personal records of the men who actually inspected them tell a different story entirely. For the 22 years between his departure from building inspection and his death in 1918, Walter Goss worked for the Pennsylvania Railroad, supervising the electrical systems of locomotive depots and rail yards across western Pennsylvania. He never returned to a civic building roof. He never submitted a supplementary account of what he had found. He never contacted a newspaper, a university, or any public official. The personal note folded in his job file stayed folded. It was not found for 45 years, but he had written the third line, the one that said he had seen the same system at the Federal Building and the post office at a different time in different ink, which means he went back to that note after he had made more inspections and confirmed what he had begun to suspect. He did not write it for anyone else. He wrote it for himself. He wrote it because he needed to know that what he was seeing was real, and that it was not an accident, and that it was everywhere. The rods are still on those rooftops. The Allegheny County Courthouse stands today on Grant Street in Pittsburgh, its copper-capped roofline unchanged from the day Goss climbed it in the summer of 1896. If you look up at the roofline from the street, you can count the rod terminals, 43 of them at measured intervals, exactly as Goss recorded. If you ask the county's facilities department about them, they will tell you the building has a historic lightning protection system maintained as part of its architectural preservation requirements. Somewhere below those rods, in the ventilation chamber 2 floors beneath the roof deck, the junction assembly that Goss connected his voltmeter to is still wired to a cable that descends through the building's interior. And in the deepest basement, if the sealed copper box that Bernard Shell found in 1903 is still there, the cable ends where it was always meant to end, not in the earth, not in a grounding rod, but in a container that 2 licensed engineers examined at a combined century's distance from each other, and neither one could open. The official history tells us that the metal rods on old rooftops were put there to protect the buildings from lightning. What the inspection records tell us, the ones that survived in personal files and private diaries and folded notes tucked into the backs of job folders, is that the men who tested those systems found something that the official explanation does not cover. Current running the wrong direction. Internal wiring that goes nowhere a lightning protection system needs to go. Coils in basement terminals that should not exist. A sealed box that no one opened and that no one, in the official record, ever acknowledged was there. Whatever those systems were collecting, it was not being discharged. It was being kept. These records survive because people refuse to stop looking. Subscribe and share this with someone who needs to hear it. History does not disappear when it is locked away. It disappears when no one asks the right question. Next week, I am following a thread that connects Rafferty's missing federal specification to a patent application filed with the United States Patent Office in April of 1889, 4 years before Tesla's famous patents, by an inventor named Cyrus Hartwell of Baltimore, Maryland. The application describes, in technical detail, a rooftop collection array for atmospheric electrical energy, with an internal junction manifold, a coiled induction terminal, and a sealed distribution assembly in the building's basement. The patent was accepted. It was assigned number 401,520. and it was quietly invalidated 18 months later, in a proceeding whose records at the Patent Office list the grounds for invalidation as prior art, meaning that someone argued successfully that the technology Hartwell described had already been in use before he filed. The prior art citation in that invalidation proceeding names no source. It is simply stamped, prior art established. Hartwell died in 1892. He never refiled. Nobody asked what the prior art was,